Hello everyone, JCE Connect. I welcome you all for this particular lecture. So in previous lectures, we have been discussed about the energy concept in open channel flow, how the energy can be written at a particular section, that is a specific energy. So that we have discussed in the previous lectures. So this one we have discussed in the previous. This is very important concept in a open channel flow. At a particular section, how the energy can be written and the total energy as well as the specific energy. The specific energy will be taking with respect to the channel bottom, that is pressure head plus kinetic head. Pressure head plus kinetic energy that represent the specific energy. So in this particular lectures we are going to discuss about the how the specific energy curve can be drawn and how the curve can be understood, and various parameters in that curve we will understand by drawing the curve. So what the specific energy curve generally represents? It is a variation of specific energy with flow depth is called specific energy curve. There is variation of specific energy with flow depth is called specific energy curve. So because as we have discussed in the previous lecture, the total energy along the direction of flow, the total energy along the direction of flow always decreases, whereas the specific energy, it may increase or decrease along the direction of flow, because it depends upon what? It depends upon the flow depth. If the depth of flow increases, then the specific energy get increases. If depth of flow decreases, then specific energy get decreases. So along the direction of flow, it may increase or decrease, because the variation of specific energy with flow depth is called specific energy curve. So let us consider one rectangular channel section to understand the specific energy curve. Let us consider one rectangular channel section. In that channel section, let us consider steady uniform flow. So we are considering the rectangular channel section, and in that rectangular channel section we are considering steady uniform flow. So let us take B as the width of the channel at bottom and Y as the depth of flow in a section, and the Q represent discharge through the channel, that is in meter cube per second, and Q by B, which is been taken as discharge per unit width of the channel. It is, that is meter square per second. This is meter cube per second and this is meter, so 1 meter get cancels, you'll get meter square per second. That is called discharge per unit width of the channel. Then the average velocity of flow through the channel can be given as V equal to Q by A. We know this formula. Then Q equal to what? Then V equal to Q divided by, substitute the area B into Y. That is rectangle channel where here we are considering, that is B into Y. Then the V becomes Q by Y, because this Q by B is what? Specific discharge or through the channel, that is discharge per unit width. So that is taken as Q. Then the specific energy can be written as, if we substitute in specific energy equation, what we get? E equal to Y plus V square by 2G. If we substitute the value of V here, then Q by Y whole square divided by 2Y, then we get Y plus Q square divided by 2GY square. Then the specific energy can be written as E equal to Y plus Q square by 2GY square. So with this equation we can draw the specific energy curve. By having this equation we can draw the specific energy curve. The specific energy curve is a combination of two curves. So this equation itself can be splitted into two parts, hence it has a two curves. Here it is the specific energy curve is a combination of two curves. One curve is E equal to Y and another curve is E equal to Q square by 2GY square. Then one can write, so this E equal to Y is nothing but which represents the straight line equation, which is a 45-degree line passing through the origin. One can written as E equal to uh, here we know that Y equal to mx plus c. So here the c is taken as a 0, that is the intercept is taken as a 0, and m can be written as tan theta. And the equation of straight line, when you draw the equation of straight line, and if the line is starting from the origin, then c becomes 0. In this case c becomes a 0. When you draw a line, straight line, then this represents y equal to mx. So in this case, wherever you take a slope, this is theta, then m represents tan theta. So when you get to this straight line, when theta is 45 degree, when theta becomes 45 degree, m will be 1. Then this, when theta is 45 degree, then m will be 1. Then what we get? Y equal to x, like this. So the same thing here, E is y. It means the line is passing through the origin at an angle of 45 degree, which is a 45 degree line passing through the origin, which represents the straight line. This is one curve. And this one more is E equal to q square by 2g y square. In this one, let us take this is a constant term, can be written as k divided by y square. So where it represents hyperbolic or hyperbola. This represents what? Hyperbola. Okay. Then again, as I said, the specific energy depends upon the depth of flow. As the depth of flow increases or decreases, the energy changes. If it decreases, energy increases. If it depth of flow increases, the energy decreases. So this specific energy curve is a combination of two curves. One is a straight line, other one is a hyperbola. So how it can be drawn? I hope you understood this one. So the specific energy is a combination of two curves. The specific energy curve is a combination of two curves. One is a straight line and other one is a hyperbolic curve. Okay. So how it can be drawn? Here, I'll draw the specific energy curve here. So along the y-axis, let's draw y-axis. Draw y-axis and x-axis. Along y-axis, let us mark the depth of flow y. Along x-axis, mark energy, because energy it depends upon the depth of flow. As we defined the specific energy curve as the variation of specific energy with flow depth. As the depth increases or decreases, specific energy varies. So as we know, the specific energy curve is a combination of two curves. That is, one curve is E equal to y, and the curve is E equal to q square by 2g y square. So let us draw the first this curve. This curve represents what? The straight line. This one, equation of straight line. So this curve represents the equation of straight line. First you have to draw equation of straight line, so which is passing through the origin at an angle of 45 degree. So draw this at an angle of 45 degree, this one. So this is at an angle of 45 degree, and this curve represents E equal to y. This is the first curve. Then the second curve, here we are having the second curve from this equation. You can see this equation, this one. This second curve represents, as the depth of flow decreases, energy increases. Even as the depth of flow increases, energy decreases. Okay, so that it is a hyperbolic. Then one can be drawn like this. Like this. So it represents what? As the depth increases, energy get decreases. As the depth decreases, energy increases. So if the depth increases, energy go on decreasing. If the depth decreases, energy go on increasing. This is the curve. Then this curve, which is represented, that is this curve represents E equal to, that is q square divided by 2g y square. This curve. I hope you are understanding this one. The one curve represents the straight line equation and the other curve represents the hyperbolic equation. Then the combination of these two will be the resultant, the final resultant, which one can draw when you combine together, that is E equal to this one. When you combine together this one, y plus q square by 2gy square, the final curve what we get is like this. We get this final curve. Okay, this is the curve. So this curve, what we call as a specific energy curve, E equal to y plus q square by 2g y square. Okay, so let us name for this curve T, and this point you take it as a C and B. The curve DCB is known as specific energy curve. Okay, the curve DCB is known as specific energy curve. In this the specific energy curve, let us mark this point as a C, and this corresponding to the point C, so we get here corresponding to this point C, so when we draw a tangent to this point C where slope is 0, if I draw a tangent here, the slope will become 0 corresponding to this one. So whatever energy we get, that energy will be minimum specific energy. The energy is minimum at this particular point, and where the slope will be 0. And corresponding to the minimum energy, whatever the depth you get, because the along x-axis what it is representing, energy. The corresponding to the point C, I have marked the energy on x line. That energy is nothing but minimum specific energy, and corresponding to this energy, whatever the depth of flow you get in a channel, that represents critical depth YC. Critical depth YC. So this is one line with respect to this one. So we can classify the flow in channel with respect to the critical line or critical flow. This line represents the critical flow in a channel, this one. If you take above the critical line, that represents one type of a flow. If you take a below the critical line, that also shows one type of a flow. So that is defined by a Froude. So if at this particular line, if the flow exists, this represents the Froude number, which is at this particular point the Froude number is equal to 1, and when the Froude number equal to 1, that flow is represented as critical flow. If the Froude number is more than 1. So where you get Froude number is more than 1, the Froude number, if it is greater than 1, this flow represents supercritical. In above 1, the Froude number will be less than 1. This flow represents subcritical flow. So in this region we get a subcritical flow. In this region we get a subcritical. This is critical and this is supercritical. Okay, so in this curve itself we can classify the type of flow according to the Froude. If Froude number is equal to 1, that represents critical. The critical flow, when it occurs, when the energy in a channel or the specific energy in a channel is a minimum, corresponding to that whatever the depth we get, that is called as a critical depth. At critical depth the Froude number is equal to 1, that is called critical flow. If Froude number becomes less greater than 1, when the Froude number becomes greater than 1, when the depth of flow decreases in a channel. When the depth of flow decreases in a channel, energy increases. The energy of flow will get increases, the velocity get increases. If the depth decreases, the velocity get increases. As the velocity get increases, obviously the specific energy get increases. That type of flow represents what? Supercritical. Means high speed or a high velocity flow. High velocity flow is represented as supercritical flow, or it is also represented as rapid flow. And subcritical means slow motion. Slow motion, as the depth increases the energy decreases, the velocity also decreases. That is called subcritical flow. Okay, so this is the type of classification of flow. And also uh, the depth of flow, uh, except point C, for every values of specific energy, two flow depths except point C, wherever you take, except this one. If I draw here this one, if I draw here except point C, except point C, wherever, if I draw a line like this, you will be getting two depths, y1 and y2. So let us take this as a y, this as a y1, one depth you get y1, this one I will mark it as a y1. Okay, one more depth you get, that is here you get a one more depth, this depth is y2. So except point C, except critical point, wherever you draw a line on the curve, wherever you draw, you will be getting two different depths for one particular energy. So these two different depths will be giving you one particular energy. Let us take this energy is E1. If you take here, the energy giving is E2, but it will be giving you two depths, and two depths, and also this particular point gives you the area 1, area 2 here, and this is area 1, and these are the two depths, and these two depths are called as alternate depths. And one can be written the uh, one can be written the energy here. So how the energy can be written here? See, energy will be, this is from here to here, it is y2. And what about velocity? Y2, this will be the velocity, then up to here, this becomes v2 square by 2g. If I take this as a depth y1, and here the velocity will be, that is v1 square by 2g. So what it represents, if I take a rectangular channel, if I take one more rectangular channel, okay, so what it represents, rectangular channel, here I am taking the two rectangular channels, try to understand this one. So here I am marked critical depth corresponding to that minimum specific energy, except point C. Wherever we draw a line on the curve, we will be getting a two depths, different depths, and same energy it will be giving. The meaning is, for a given constant discharge, I'll write here, for a given constant discharge, for a given, and whatever the curve we are been drawing here, it is for a constant discharge, only the depth of flow is varying. For a constant discharge, the curve will be drawn here. For a given constant discharge, q can be passed, that is discharge can be passed in two ways, through a fixed channel cross section with specific energy E at that section, with specific energy E at that section. See, for given constant discharge, so this curve, so here what it is, this is a critical depth leaving this point. Wherever you take, I am taking points here. This point represents the area of section 1, this point represents area of section 2, this area of section 1, corresponding to area 1. What is the depth? Y. Then this is the depth of flow in a channel section. Then the corresponding velocity is how much? This, if you take this point, corresponding velocity is v1 square by 2g. And at section 2, what is the depth here? y2. Corresponding to this is velocity is v2. Okay, then y2 plus v2 square by 2g represents what? Specific energy. So at this section, then the same specific energy we can get by having alternate depth, and these two are being calling as alternate depths. So when we can get alternate, see, suppose this is, we're having a depth of flow y1, then also we may get velocity head, this one, velocity head. What do we get? v1 square by 2g. So what is the energy here? y1 plus v1 square by 2g. Okay, so here I am given, for a given constant discharge, the discharge is passing constant discharge, here also constant discharge. For a given constant discharge, q can be passed, the discharge can be passed in two ways, through a fixed channel cross section with specific energy E at that section. Mean with the same specific energy we get in a channel section, but the discharge can be passed in two ways. What is the one way of passing? Higher depth, higher depth of flow into low velocity. That is one way. Second one is low depth of flow into high velocity. See, here we are having a two depths, y1 and y2. So y1 is higher depth, this represents higher depth, that is y1 is higher depth, but the velocity is what here? The low, the velocity is very less. Okay, so here in this case y1 y1 for y1 what is the velocity? v1. Then y1 greater than y2, y1 is greater than y2. So in this case if we take here, this is the channel, then this will be depth of flow, and the velocity what we get here, this much velocity we get, this is v2 square by 2g. It means what? For the higher depth, the velocity is less. For the lower depth, the velocity is high. For the lower depth, the velocity is high. So, when y2 we are having a depth, velocity is v2. But what about velocity here? Velocity is greater than v1. So, this velocity is v1 and this velocity is v2 here. Okay. So, what the curve represents? So leaving point C, wherever you take the points, you will be getting a two alternate depths. That two alternate depth represents the same specific energy, means the discharge can be passed in two alternate depths without changing the energy. So one way of passing is you can make higher depth of flow and low velocity, and other way of passing you can make the lower depth and higher velocity. So this is the concept of this curve. So wherever you take the curve, that curve represents specific energy curve without losing energy or without decreasing any energy. We can pass the discharge in two alternate depths, that is by having a higher depth into low velocity or low depth into high velocity. So this is the concept of this curve. And as I said, according to Froude's number, the Froude number, if the Froude number is equal to 1, it represents the critical velocity, critical flow. If it is less than 1, it is called as a subcritical flow. If it is greater than 1, it is called as a supercritical flow. So if it comes below critical, means we get the depth, means this is a below critical, this depth is below critical, obviously we get the velocity of flow is very high. So when the velocity is very high in a channel, that type of flow it represents the high velocity flow or a rapid flow, or it can be classified according to Froude as supercritical flow. Then if it is a depth of flow is high, the velocity is less. We know that velocity is inversely proportional to depth. If the depth decreases, velocity increases. If the depth increases, the velocity decreases. Okay, so that this type and these three type of flow represented one. Higher the velocity, lower the depth. Lower the velocity, higher the depth. Means higher the velocity means it is a supercritical flow. Lower the velocity means it is a subcritical flow, and in between whatever the flow we get, that is called critical flow. Okay, this is about energy, specific energy curve. So this is very important for the examination point of view for drawing a specific energy curve. So please practice this curve and try to understand the parameter what I have been discussed here. It's a combination of two curves. One is a straight line curve, other one is a hyperbolic curve. Okay, and further, for a given specific energy, for the given specific energy E at a critical point, the discharge Q will be maximum. So some of the parameters we'll discuss in next part of this lecture. that is how the critical depth can be derived, then the critical velocity. So that is and also in minimum specific energy in terms of critical depth. So in next lectures I'll be discussing about the critical depth, critical velocity, and minimum specific energy in terms of critical depth. I hope you understood these things. This one. Thank you.